Hello friends, the next topic of BJT is simplified current relations in BJT. Simplified current relationship means I will be talking about the emitter current, collector current and the base current. We will be talking about NPN transistors. So when you talk about NPN, this is IE, this is collector current IC and this is base current IB. So we will see the expressions of these currents. Fine. Now before I start with the expression, the very first thing I will be talking about the diffusion of the carriers across the forward bias junction. Remember, when a PN junction is forward biased, the major component of the current is because of the injection of minority carriers across the forward biased junction. If you remember the PN junction diode. So this junction, I am applying B positive, E negative, this is NPN. So this is your emitter junction, this is your collector junction. So emitter junction is forward biased, collector junction is reverse biased. So this is normal active mode of operation. So in normal active mode of operation, when collector junction is forward biased by the voltage VBE, the electrons, it is inside electrons from emitter side will be injected into the base. So electrons are injected into the base. And these electrons will be forming the diffusion current in the base region, and that current is what? This is INE. Why? Because when you talk about this current, this is collector current, but which is same as this. Remember, the collector current here is approximately same as the electron component of emitter current. Why electron component? Because electrons from emitter are injected into the base. These are forming major component of the current. Why? Because these are the major charge carriers in emitter region. So this diffusion current will be forming, this diffusion current in the base will be forming the major component of emitter current, and that is same as the collector current. So IC will be approximately equal to this, and that is nothing but diffusion current in the base region. Why? Because I repeat, the forward bias current in a diode is because of the diffusion of minority carriers on another side. It means diffusion of minority carriers which is lightly doped side, which is base in this case. So that is, what is the current? Diffusion dN by dx, that is the diffusion current because of electrons. Fine. So diffusion current of electrons is given by this relationship, but since it is current density, it is current, and this is the expression of diffusion current density, so I will be multiplying it by the area of emitter junction, this area junction, that is area of cross section of the forward bias junction. So I am multiplying it by the area of cross section of the junction. This is the derivation of the current which we discussed in case of PN junction diode when we derived the expression. You can just refer my top video on PN, the current components of PN junction diode. Fine. So here if you see, IC is equal to AE Q dN into dN by dx. But please remember, for this current same as this current, this relationship, this curve is having exponential relation, but for ideal relationship, if you want to have no recombination in the base region, this should reduce linearly rather than exponentially. So for, I repeat, no recombination will occur in the base region if the concentration of the minority carriers in the base reduces linearly. Exponential decay results into the recombination. That is what the concept is, you should remember. Here, if it is reducing linearly, the rate of change of concentration will be equal to, what is the slope of this line? Final concentration here is 0. What is the concentration here? Concentration of electrons in the base region is NB0. So that is NB0 means initially, that is at the edge of this point, minus what is the concentration here at a reverse bias PN junction, 0, divided by what is the value of X here, that is 0. So 0 minus WB, that is what I have. Slope of this line, slope of the concentration in base region, minority carrier concentration. So this is equal to minus NB0 into WB. But remember, if you remember the variation in concentration in a forward bias PN junction, but again you need to recall the diodes, the concentration of minority carriers at the edge of the depletion layer is equal to the concentration at thermal equilibrium into e raised to power forward biasing voltage of the junction divided by thermal voltage. This is relation we have derived in PN junction diode video, that is variation in concentration in forward biased PN junction. NB0 is equal to this. Fine. So if you have this relationship, so I'll be able to give you the expression of current, that is minus area of cross section of emitter junction Q dN into this is what, NB0 by WB, or this is equal to IC. I'll rewrite it like here itself. IC will be equal to what? IC is equal to, that is minus AE Q dN, that is diffusion constant of electrons in the base region, please do remember that, into NB0 is what? NB0 e raised to power VBE by VT divided by width of the base region. This expression is very, very important. You have a lot of questions on this expression of collector current. But remember, this was negative sign. It means current is moving in the direction which is where this concentration is having a negative slope. It is having negative slope in this direction, but current is moving in this direction. Taking only magnitude of current, if you take only magnitude, I am not concerned about the direction. So IC is equal to AE Q dN NB0, that is concentration of electrons in base region at thermal equilibrium. dN is diffusion constant of electrons in base. AE is area of cross section of emitter junction into e raised to power VBE by VT divided by width of the base region. That's it. So I have neglected the sign here. You must remember this expression. I repeat, this is very important as far as exam is concerned. There are a lot of numericals. I will be solving all the numericals which have appeared in GATE. But this topic is important for GATE exam. You don't have question in engineering services from this particular topic, but this is important for GATE. Fine. Now I will be talking about the emitter current. Here, emitter current has two components. One was this is NE. Second component is because of injection of holes from the base region. So if you talk about the emitter current, now the emitter current has two components. What are those components? Just for before I start here, what I had, IC was equal to what? That is AE. Just recall IC. AE Q dN, then NB0 e raised to power VBE by VT by WB. I will rewrite it like this. IC is equal to AE Q dN. Rather than writing this, I will be writing it like this: IS e raised to power VBE by VT, where what is IS? That is nothing but, we call it as, that is reverse saturation current or leakage current, whatever you give the name, that is EE Q DN and B naught by WB, just for reducing the expression. Fine. So sometimes we call IS as saturation current, so just remember that. Fine. Then let us talk about emitter current now. Emitter current is IE, has two components, I and E plus I and not N, I and P. There are two components. Fine. I'll be taking these two components here itself at the edge of the diffusion region, at the edge of the diffusion layer. One component I and E I have already seen, that is what? IS e raised to power VB by eta, VT. You know what is IS? That is area of cross section of emitter junction, Q, DN and B naught by WB. That is one component of emitter current. The second component will be IPE, and that is current at this point itself, at the junction itself. And again, please do recall the current component of current in diode, that is equal to area of junction Q DN N E naught by L N, that is not N, that is LP. This is, and this is DP naught, I'm sorry, I'll be making correction here, DP, and this is PE naught, DP PE naught by LP. Please see this, how it comes. One component of, because of electrons which are injected from emitter side to base side, that component is because gradient in base region. If total current passing through the junction is what? One is because of this injection of electrons from emitter to base. Second component at this point is what? Because of injection of holes from base to emitter. So one component of current at this point is this, second component of current is this. This is because of injection of holes from base to emitter side. This is because of injection of electrons from emitter to base side. So I have already obtained the expression of this component of current, that is I and E. I need to find the component of current because of injection of holes from base side to emitter side, and that will be giving me the current. And that component of current is given by IP is equal to area of cross section of emitter Q dP P naught, because it is because of concentration of holes which are injected from base to emitter. So diffusion constant of holes in emitter region. Remember, this is diffusion constant. I repeat, in this expression, Dn is what? That is diffusion constant of electrons in base region. Please remember, what is dP here? Diffusion constant of holes in where? In emitter region. Please do remember, both are different. This is for base, this is for emitter. This is concentration of electrons in base region, this is concentration of holes in emitter region at thermal equilibrium. This is width of the base region. This is what? This is your diffusion length of holes where? In emitter region. Please do remember these points. Into what? E raised to power VBE by VT. Please try to recall the equation of diode current. I am writing that equation directly here. So this is what? IPE equal to IS1 into e raised to power VBE by VT, where IS1 is what? Again, the saturation current, you can say, that is AE Q dP PE naught by LPE, that is the diffusion length of holes in emitter region. Please do remember all these points. So what will be the total emitter current? This gives the total IS, let it be capital IS, capital IS. So IS plus IS1 into e raised to power VBE by VT. This is the expression of emitter current. As said, there was no question in past till date, but you cannot neglect the possibility of question in GATE exam from whatever I am discussing, because there are questions in past from the collector current. So you cannot neglect emitter current as well. There can be question from this part as well. So this is emitter current. Now interesting part is, we know what is alpha. Try to recall, alpha is the ratio of the collector current to the emitter current. That is common base current gain. And you know what is this? That is Is into e raised to power VBE by VT divided by Is plus Is1 into e raised to power VBE by VT. This factor is common on both sides. So this gives alpha equal to Is by Is plus Is1. That is common base current gain. And if you recall, what is Is? That is N, I'll write AE Q D diffusion constant of electrons in base region into NB naught divided by what? WB whole divided by AE Q DN and B naught by WB plus AE Q DP PE naught by LP, that is diffusion length of holes in emitter region. So alpha here comes out to be 1 by 1 plus, you can take it common, or that is Is upon Is. So this is what? DP PE naught into WB, that is width of the base region WB by DN and B naught into LPE. This is the expression of your common and base current gain of BJT. Although there was no question on this in past, but I cannot say that you cannot simply neglect it. Fine. Now, what is the relationship between the collector current and base current? What is that? The base current. Now, last part of this topic is, that is base current. Base current is what? Base current IC is nothing but beta into IB. And what is beta? We have just seen that is alpha upon 1 minus alpha into IB. So what is IB? IB is nothing but 1 minus alpha by alpha into IC. And you know what is IC? 1 minus alpha by, or you can say 1 by alpha minus 1 into IC is what? Is into e raised to power VBE by VT. That is your base current. So what I find here is base current is also proportional to e raised to power VBE by VT. So what I find in all the expressions of collector current, emitter current and base current, I have this exponential term. It means all the current components in BJT are controlled by the forward biasing voltage of emitter junction. That is the observation. Otherwise, as far as exam is concerned, there are questions on collector current. We will see in separate video the questions of GATE which have appeared. This topic, as there was no question in engineering services, but very important for GATE exam. So I'll be showing you the numericals which have appeared. I'll be solving the numericals which have appeared till date from this particular topic. Just wait for my next video to come. Thank you for watching the video.